Are you using AI coding assistants effectively in your work, in software development? I want to discuss today about 3 common mistakes that I noticed in the past year working with real teams, with real developers who use AI coding assistants, and how to avoid those. Welcome back to Think Design Work Smart. I'm Alex Bolbak and I'm coming at you from the Mosaic Work Studios. And today I want to talk about the 3 top mistakes I see people doing when using AI coding assistants. The very brief version, there are 3 big tasks. If you are giving a task that's very big, unclear prompts, if your prompt is not covering all the bases, not verifying output, if you believe that it will always generate good output, and I have an extra one, not using the models for everything they can do, just for generating code, but not for additional tasks like research, critique, reviews, or conversations that help uncover things. If you know the answers to all these problems, then thank you for watching. If not, keep watching. So, first problem, big tasks. Here's a common scenario. You get a big piece of code and you're thinking, okay, let me just use an assistant to explain this to me. And you ask for explanation, and what you get is not really anything useful, or something that is wrong or not completely correct. Part of it is because of you need to verify the output, and because of the inherent limitations of the models, which will understand code but not necessarily the very specific things from your code base, because that's what they were trained on. But most likely the first problem is that you're asking for a very big thing. And right now these models are not as good for big tasks. Sure, you can go in plan mode, you can ask it to plan and then to do step by step. But in order to let it do that, what I prefer is to first understand how to do this. And here is where incremental thinking comes into play. So if, for example, if I'm working with a big piece of code, first what I like to do is to work at a high level of abstraction and see, can I make a map of the modules that are involved? Then can I see how these combine with each other? Could I make a diagram? Then can I go in each of those files and get a description? And if those files are too big because there's a lot of lines of code, then maybe we need to do something different and just take them class by class and so on. And the reason for that behind the scenes is that the memory used by the model when you send the prompt and when it's processing the prompt, it has a limitation of context window. Basically, that limitation comes from the limit of the memory that it can use for a query. And the worst case scenario is when the context window is O of n squared, where n is the number of tokens. So it is proportional with the square root of the number of tokens passed in. It's a little bit more complicated than that. Now, there are, of course, optimizations that companies are doing around this, but this is the worst case scenario. And when it overflows that memory, basically it picks whatever fits, and it's a random part of the model, which means that it will give you random results and not the best results. And because of this, context window management is very important, and the way to deal with this is to work incrementally in smaller tasks. The second problem that I see is unclear prompts. People write prompts like, give me a diagram for this system, or give me some code that implements this, and it's usually not enough. The prompt The best prompts define a role, so persona, act as a something, act as a software architect, or even better, act as a specialist in e-commerce who happens to be a software architect, or act as a software architect who specialized in e-commerce. And the reason why this works is because by specifying this persona, certain weights are recomputed. So basically inside the model, it can go, well, let's say we simplify, one to the right or to the left. And if you don't specify any context, it will just go in the general direction. But if you specify something that's more fine-grained, it will just pick from the model the part of the model that best fits the specification that you pass in. So it's more likely that it will give you good results or results informed by previous work in the same domain, which makes it really useful for specialization, for specialized tasks. So unclear prompts, make sure that your prompts are clear, that you specify a persona at least, if not more. There's a lot more to discuss here, but just by specifying the persona, you get further. Second tip here, if you use something in the prompt in the form of ask any questions you might have, the model will first ask you questions about your request before actually trying to generate what you're asking from it. And this will make the results much better. So if you do these two things, specify persona, ask any questions you might have, you already have clearer requests. Third, output not checked. If you don't verify the output, don't be surprised if it's incorrect, or if it hallucinates, or if it just doesn't give you a result that makes sense. The models are optimized to give you results that look kind of correct, because the interest of these organizations that are training the models is for you to have longer conversations. And because of that, they need to be pleasant, or to give you something that seems correct. This can mean that occasionally it is correct. It can also mean that occasionally it just makes things up, or it just works, produces results that are quasi-correct but not quite. So you need to verify everything. Now there are three ways in which you can verify things. First, deterministic tools. This is useful in software. For example, if you generate code, you can run tests on the code. The tests are deterministic, but this assumes that if you use the AI to generate the tests, you have verified as well that output. So pay attention to this. You need to generate tests that you can trust. So you could generate tests first, and remember, big tasks. We don't want to have big tasks, we want to have small tasks. How do you do this for tests? Well, you first ask for a list of test cases. You review the list of test cases. You then ask for the implementation of those tests. You review the implementation, and so on. So incremental, once again. And assuming you have the correct tests, then you can ask to generate the code, and now you can run the tests against the code, and you have a deterministic way of showing that the code is doing what it's supposed to do. If you add mutation testing to the mix, you can actually capture and restrict the code to the behavior that you want. Because pay attention, sometimes assistants will generate too much code, not only the code that you need, but also extra code that might prove a problem later on. Security issue, performance issue, whatever. So first step, deterministic tools. You can also use other types of tools like static analysis, or for security, static security tools, dynamic analysis, security tools, and so on. Second step is review with AI. You can ask the AI to review the code against specific guidelines, needs, rules that you set up, and that can work pretty well. I like to challenge whenever it generates code, say, okay, is this the simplest solution? Do we need that piece of code? Can we remove parts of it? Why do we need that? And so on. Explain what you've implemented. Third level, and by the way, second level AI, same rules apply. You need to check the output. You need to take action based on what you get. And third level is human. Once you've done tools, AI, you then take a look and make sure that everything is still correct. So these are the three ones, and I want to add a fourth one. I like to give you extras, so this is the extra one today. The extra is not using the models for all the things they can do. We are familiar now with the fact that you can use GitHub Copilot or Claude Code to generate code. But it can do so much more. It can help you select a technology. It can help you learn about technology. It can help you with research. It can help you with reviews. It can help you with critiques. So some of the best parts in my activity of using Claude have not been in actual code generation. I've done the fair bit of that, but they've been in exploration. Let's explore this idea. What things exist here? What other domains can we use? So for example, I design courses mixing in elements from game design. And that's how our learning programs are designed nowadays, with elements from game design. You have quests and you have achievements. I have looked at how to include elements of complex adaptive systems and systems theory and game theory, adaptive game theory, into agentic workflows. I have looked at what technologies I can use for various things, and I have compared technologies. I have explored, starting from a problem, I've looked at the problem and said, okay, so we have these elements in the problem. What are the things that we can use? Let's see 5 alternatives, and then discuss those alternatives. And in the process, learned about a bunch of very useful technologies. I have discussed moonshots, things that would be really nice that I don't see practically applicable right now, but in discussing those moonshots, you can figure out what things you can use in your systems in order to make them better. So there are a lot of things that you can do with these assistants. And let me just give you 2 practical ones, reviews and critiques. These are different. If you ask your assistant to review a document, it will give you some light, improvements or thoughts. But you can ask it to critique your document, let's say your architecture diagram or your architecture decision record or your threat model or your solution or your code. And you can ask for critique, and it will then give you a lot more things that, okay, some of them don't apply, but it's good to have a longer set of critiques, of points to improve in order to be able to pick the ones that are really useful for you. And you can also do this repeatedly, particularly if you want to have really good outcomes. You can ask for a critique 3 times or 4 times, and yeah, at some point it will start reaching and not giving you something that's really useful anymore, and that's when you know you can stop. but you also know that you've done your best to get to the point where you have good systems, good artifacts that you generate. So to summarize, 3+1 problems that you need to avoid: big tasks, unclear prompts, not checking output, and the extra one, not using AI for all the things it can do to help you. Behind all these things, there are notions of token management and managing the token economy and context window management and skills and subagents and associating subagents with skills and tasks and so on. And if you want to learn a lot more about this topic, join our AI-powered software engineering course, where we go through all the phases of software development from the initial problem all the way to the implementation. Use AI to get from problem definition to implementation, and make sure at each step that you are using AI effectively. It's a really great course. It got really good feedback. And check our website for the next times where we have it planned, or ask for it inside your company. And if you want something customized, let us know. We're always customizing courses for our clients. So what do you think about all this? Any other tips that you'd like to share? Any other comments, questions that you have? Let us know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.